Good afternoon to everyone. Let's discuss about Matlab figure plots. So for that we need to get into Matlab. So I have Matlab R22 2020B version of the Matlab version. So I have opened a new window over here. So I don't want to go into the basics of the Matlab. I am assuming that you all know how to use the basic Matlab. So provided that this is an editor window, so I am starting from here. So CLC clear all. So these are the two basic commands. So this complete lecture or this tutorial, whatever I am going through for the Matlab plots, is for the people who do research. Let us suppose there are a lot of researchers who want to publish their papers in like high quality journals such as IEEE Transactions or Nature Electronics and such kind of journals. So for them, how we need to adjust the figures easily. So you will learn that in this particular tutorial. So for that, what I am doing is CLC clear all. Then I am defining a function. So defining Matlab function. Let us take an independent variable x, which varies from, let us say, -10 is to 10. So if I write -10 is to 10, that means it increments from -10 at an increment of 1 from -10 to 10. If I put semicolon, that will not display in the command window. So I hope these all things you already know it. Then let us suppose I am writing a quadratic equation, x square. So a dot should be written over here, plus 3 into x plus 2. If this is a quadratic equation, let us say this is an analytical equation, that means analytically evaluated equation. As of now, I'll write it as analytical equation. Okay. Then I will write a plot command. You may ask me why I have written ANA over here. You will understand later in the video. So this is a 2D plot command. So in this tutorial, you did not need to remember any command. Generally, people say a lot of commands, right? In plot command itself, there will be so many commands that you will be trying to remember. You should never remember any command. So Matlab is a self-explanatory software. A lot of things you can learn by yourself only. So but you have to know how to use it. So that is my aim in this tutorial. So first figure, then plot. Let us say x comma y. That's it. You should only write this much only. So if you write this much, if you save it, then you can use this run command over here. I had not saved it, still it is untitled only, so I'm not saving it. So I'm just clicking the entire section, whatever is there, and I can do evaluate selection. So okay, it is saying unrecognized function y. Okay, sorry, it is y, it is not y, it is y ANA. I'm extremely sorry for that. Now you got this as the figure, right? Now what we can do is, you go to the view, go to the property editor, view, plot browser, and you can adjust this to the as much as close to the entire box and entire window. The reason is, if you keep this white space, I mean if the space is there, then that will also reflect in your paper. So in your paper also that white space will be created. So always try to maintain as minimum as possible. The space should be over this, so that the entire figure will be covered in your paper. So when you call it in the LaTeX file, or when you call it in the MS Office file. So first thing is what? Now you see here, there is nothing like X label. We don't know what is X label. We don't know what is Y label. Nothing is known, and this figure is not even clear. So we have to make this clear, a high quality one. So how to make that? So first thing is, so the moment if you click on this window, let us say if I click outside this, so I have clicked on the outside the figure, then you will get property editor figure. So in the property editor figure you have three commands: figure name, so you not mention any figure name; color map is used for the 3D ones, not to the 2D ones, so this is a 2D plot, so we are not using over here, but figure color. So figure color, right now you can see the gray one, the background you can see over here is gray one, so that should not be gray one, it should be always white, remember this. So once you have done this, next you have to go to the outermost one has been completed, so the next innermost one is you have to click on the figure, that is property editor axis. So there are two axes you can see, one is in the below is x axis, the left side is the y axis. So now you can see already x axis is selected over here, so you can write the x label. Let us suppose this x is a function in seconds, so I have written that, and the y is velocity function in meter per second, so I'll write m per second. So then I should also change that in the similar way, so I will write SCC over here, so that is the symbol for seconds, so I will write here also SCC. Maintain consistency. Second, after that, once you have labeled x and y labels over here, you can see you have labeled that, so you can also change the font. So font is very small over here, so now you have to increase the font to I will increase generally to 16 to 20 is good for me, so 16 is okay right now. Now you have to also if you want, you can also on the grids. Then in the innermost you can click on this line graph. In the line graph you have, first thing is plot type. There are various plots, this is the line plot, so you can actually go on to the bar plot if you want. If you want, you can also select area plot, so area under the line. So if you want, you can also use stairs. So if you want, you can also use stem. So among all the things, right now I am targeting on line, let us suppose, and the color, let us suppose, once you understood about this plot type, now you can also change the colors as per the requirement. So generally you can choose any color, so you can see there are multiple colors over here, and if none of the color you wanted from this, you can also go to the more colors and you can select the colors from this window also. So I'll just maximize this. Okay, now I will choose this color, the blue one. Then I will also try to increase the width of this, so you can increase the width from 0.5 to 30. If I use, now currently it is 0.5, if I use 30 it will be very big, so that is also not good. So 2 is ideally very good for the plots. So next you can use the line type, either -1 or ~1, or you can change the .1, it's up to you. So for different commands you can use different things. So let us keep it as a line 1, a complete line. Then also you can select the markers. For the markers you can use plus or circle 1 or cross, square, diamond, V-shaped or inverted V-shaped, pentagon, hexagon. There are multiple things, you have various options for this. So let us take a circle. So at those positions, at -10, -9, -8, -7, -6, you will have a circle over here. Now you can see the circle is not at all visible. So what we can do, we can actually increase the size of that circle. So right now I have increased to 15. If you want to fill with this different color, you can do that. And also if you want to remove the line, now I can also remove the line. Now if you want to put the same color as the line, that also is possible. Or if you want to put same color as the blue, that is also possible. So that is up to you, like how you want to show to the various other audiences in your research paper or the readers. It is completely up to you. Now let us suppose I wanted to keep it in this way. and then I also wanted to keep a legend. So if you click on this over here in the red and blue one, so this is legend, and now click on this, just a minute, sorry, yeah, now you can write it here. Let us say this is a quadratic equation, let us say I will not write quadratic equation, I will write velocity function. So I will write analytical velocity function. That's it. Now you understand. I hope you understood why I have written analytical velocity function. The thing is, I am assuming the whatever values I have got here is analytical. Now I have to adjust this. So with right arrow you can actually move this closer to this by clicking on that. Then again you can adjust to this corner. Yes. Yeah. Now it is perfect. Now this is the analytical velocity function. Now not only that, so once you have done this, now you want to actually compare this result with something like measured values also. How you can do that? So for that, I'll go back to the editor window. Now here, let us suppose y measured, I will write it as MEA is equal to y analytical plus, let us take a random function rand of size same as y analytical. So this should be not capital Y, small y, sorry. So y ENA. Now what it does is, this y measured, now what I am doing is I am slightly increasing an error by adding some random numbers in the analytical function. This random numbers, if you write only rand size of y analytical, it will take the values from 0 to 1 only. So it will increment the values only from 0 to 1, whatever random values, and the size would be same as y analytical. So if I run this, okay, I'll just run this. So I can, it is only sufficient to run y measured, no need to run the entire thing. Say now if I put hold on here, hold on, and I'll put a plot command over here, x comma y measured. So I can plot this. Now if I write figure here I haven't written, some people will write figure 1. So always it will plot on figure 1 only. If I will only put figure, then what happens is it will create a new figure. Now whatever figure I have created over there, that is figure 1. Now it will take figure 2. Now if I run this, it will give figure 2, you can see, with measured and analytical values. So what you can do is, I'll go to view, I'll go to property editor, same. So already we have done in figure 1, you can see over here. Now figure 2 is for both, there are two plots over here. So I'll put first legend so that you can clearly see data 1 and data 2. So data 1 I can edit as velocity, what it is, velocity, analytical velocity function, right? So it is analytical velocity function. Sorry. Next is measured velocity function. I am assuming this is the measured data. So you can take the realistic measured data in your function. So I just wanted to teach you how to use this, how to adjust the plot commands. So okay. So this is very simple right now. I have adjusted this. First outer one, I'll put it in the white space. Then this one, x-axis would be x in seconds. Y would be v in meter per second. and let us say font, we can change it to 16. So you click on that, click on the right arrow to bring it closer to that, click on the bottom one, click on upper arrow to bring it to top. Now you can click on the blue one. See, if you are unable to understand which one is blue, which one is this, so that is also simple. You can click this one directly. You can see in the plot browser I have clicked on analytical velocity function, automatically you will get the blue one. So I'll take this one blue. I will take the size of that should be 2. Then I'll keep this dashed line, and I'll click on the measured data. Measured data, I want to put a markers. So I want to use, let us suppose this time I want to take an upper marker like this, which dimension is 15, and red, and this I wanted to put it as 2, and I'll put none. I don't want to use it. I'm sorry. Yeah. Now you see, this is the measured data, the red ones, and the dashed one is the analytical function. So these both are collaborating in a very good way. So in this way it is very clear to visualize. I'll also on the grids. So you can adjust this also to whatever place you want it. So you can keep it here, 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 here. It's up to you. So in this way you can adjust that also, this one. So this needs to be this can be shared in three saved in 3 ways. One is file save as. If you go, you have altogether three main options. One is Matlab fig file. Obviously you have to save this in Matlab fig file, because if you want to edit anything in the future, so for that you want only in figure file you can edit. So the fig file is very important. And the second one is EPS file, .eps file. If you are using LaTeX, you should always save it in .eps file also. Then if you are using a doc file or MS Doc or something, if you are using if you are writing the paper in that, then you have to use it in JPG, or you can convert it into PDF. That is up to you. JPG or PDF are the possible options for that. So in this way you can save it. So that is for this. I'll just close one. I hope you understood how to use the figure plots using this. Now I will give. I'll get into more interesting things in the 2D figure plots. So I'm just eliminating this. So now I will take my x-axis from 1:2. Let us say at an increment of 5, I want to 25. Okay. Now I'm taking a function. Let us say the same function. Let us keep it. Not the same function. Okay. We'll keep the same function. It is okay for me. So there is nothing like measured and analytical. So I just wanted to keep it as only y. I'll just remove this. Now again I want to run this function. So I'm doing clear all and CLC. Okay. So till 25. Okay, it is increasing a lot. Just a minute. I will. One is to 5:25, right? I have taken. That's a problem. Yeah, now it is perfect. Because I have taken 1:5:25 means after 1 it will take 6, then it will take 11. So 25 will not come only. So okay, now I have got this function. Now again I am going to view. Always you have to go to the property editor. Just a minute.